All right, in this video, we're going to talk about the summary from the 4.2 classwork investigation, which is how can we see, kind of compare what's going on in a scenario, in a graph, and in an equation. We also could look at the table, but we're not going to go there today in this video. So if you'll recall, if you haven't, you should go back and watch the video of the balls that go down the ramp. So this is the original function here, and this is a ball that starts at the top of the ramp. It gets let go, it slides down the ramp. The input is the time. All right, so there's a video, so the time from the start of the video. The output is the distance from the start of the ramp. As you can see in the blue one, it starts, the distance doesn't increase that much, but as it goes down the ramp, it starts picking up speed and moving more and more quickly. And that is due to gravity. So this is kind of, we can think of it almost as a little bit of our parent function. So this is just affected by gravity. Okay, now there are two other balls where I have changed something in the scenario, and we're going to see what effect that has on the graph and on the equation. So the second one is the red. And on the red ball, I dropped this. I started it 3 feet down the ramp. So it starts 3 feet from the top. So that means that its distance from the top is always 3 feet more than this blue ball. And again, if you go back and watch the video, you'll see that the blue and the red are always 3 feet apart from each other. And if you look here at the distance between these two curves, it might look like they're getting closer together, but they're actually not. It's just that the blue one goes on for a little while longer. These two graphs are always 3 units from each other. So the red graph is just the blue graph, but it is translated 2 units up. Translated up 2. So let's think about the fact that we say the word up. Saying the word up means that it is a vertical translation. So the effect that this has is on the y-axis, on the dependent variable. I changed the distance. Oh, I wrote 2 here, but I meant 3. But hopefully I've been saying 3 the rest of the time. Translated up 3. We see that 3 right here, this plus 3. This is not in the argument of the function. This is kind of happening after the function. So after gravity takes effect, I add 3. So this is happening to the output of my function. So we can see here that the distance changed. We know the distance changed because we can see that it shifted up 3. We also know that it was the distance that was affected because it is not in the argument of the function. Now, if we want to look at the purple, so this purple ball that I dropped, again, you can go back and watch the video. I dropped 2 seconds after I dropped the other balls. So 2 seconds later. Okay, now let's look at that. The blue ball here starts at 0. The purple ball starts its descent at 2. So at 2, it hasn't really moved yet. 1 second later, you can see the blue ball is here. The purple ball reaches that distance at 3 seconds. The blue ball gets to the bottom of the ramp. It's done after 2 seconds. The purple ball reaches that after 4 seconds. The distance now horizontally between these two graphs is always 2. So now, because I'm talking about seconds, I translated this graph right 3. I'm sorry, right 2. Because it's to the right, because it's horizontal, I know that I've changed the time. I have changed the independent variable. And that's this 2 right here. You can see that 2 is inside the argument of the function because it's part of the argument of the function. It's part of the input of the function. It's affecting the independent variable. So before I take into account the effect of gravity, before I square it and multiply it by 2.3, I subtract 2. So I change the input, I change the time before I let gravity have any effect on it. Notice here that I subtracted 2 to translate it to the right. And I think about that as if I'm at 2 seconds, I actually need to know those first 2 seconds didn't count. I have to get rid of these 2 seconds because gravity had no effect right here. Nothing was happening for those 2 seconds. I can't even spell. Nothing was happening on the ball for those 2 seconds. So instead of saying 2 seconds later, I like to think of it as a 2-second delay. So since I'm on a 2-second delay, I actually subtract 2. And so even though it is shifted to the right, this shift to the right is not adding to, it is removing those 2 seconds from this function. It's getting rid of those first 2 seconds. When I am at second 3, gravity has only been affecting the ball for 1 second. So all I plug into my function to think about gravity is 1. It's only actually been happening for 1 second. So I get rid of those 2 seconds where nothing was happening. This is the h parameter. That is why it is always subtracted. So when you move left and right, you move the opposite direction of, well, you move kind of opposite. If it's subtracted, you move to the right. This is k, and this acts just as it is. +3 moves it up 3. So in general, this video should help us to think about why we do -h. Why h is being subtracted, but k is being added. So h, we have to change the sign to think about how it moves, and k, we have to keep the sign.